right, so today we're starting 12.1, which is parallel lines and transversals. And what we're going to be learning, which is stated in our learning goal that I want you to write down, is that I can find angle measures when a transversal intersects parallel lines. So our first question is, what is a transversal? A transversal is a line that intersects two or more lines. So for example, if I draw a line down A and B, since it crosses through both A and B, this is a transversal. The next question would be, what is a parallel, or what are parallel lines? And parallel lines are two lines that will never meet or cross. They are equal distance apart from each other, which means they have the same slope. And we learned about slope way back in quarter 2 when we were working on graphing, but that is the slant of the line. And so since they both have equal slopes, it means that they are going to be equal distance apart from each other, which means that they are parallel and they'll never cross. So we're actually going to skip all of the exploration and we're going to go down here to finding angle measures. And so when we're looking at angle measurements, and we're looking at two parallel lines cut by a transversal, there's a couple things that you need to know about this image. First, where the numbers are, those are the angles that we don't know their measurement. So the highlighted one, that is not 1 degrees, that is angle 1, which is represented right here. And that little sign that looks like a less than actually means angle. And that means that we need to find the measurement of the highlighted section, angle 1. The next important part of a graph is to look to see, at this image, is to look to see if there are these two little arrows. If there are two arrows on the two lines, then that means that those two lines are parallel. And so since they both have little arrows that are slicing in those graphs or drawn in that image and not just on the ends, that means that the two lines are parallel, which means they'll never actually cross. So think of like a railroad track or a ladder. Those have parallel lines on them. So let's start with A. It says that angle 1 and the 110 degree angle are corresponding angles formed by a transversal intersecting parallel lines. The angles are congruent. Congruent means that the two are equal. And so since they are equal, or since the angles are congruent, that means that they are the same measurement. So we know that they're the same measurement because of this right here, where it says corresponding angles. So let's go up here to corresponding angles, and let's jot down that definition. So the definition of, I don't know what's happening. The definition of, oh my goodness, you guys, I'm so sorry. Just gonna go over here. Of corresponding angles are when they are two parallel lines that are cut by a transversal, and when they both lie on the same side of the transversal in the same position. So if we go back to our example, you'll see that both angles, angle 1 and the 110 degree angle, are both in the bottom left side of lines A and lines B being cut by line T. And so since they're both in the same position in that bottom left corner, they are equal. And the only reason that we can say that they are equal is because of these two symbols right here saying that they are parallel. So we know then that angle 1 is actually 110 degrees. So in part B, it is saying that angle 1 and 2 are supplementary. Now we have learned about supplementary angles before, and supplementary angles, if you remember, we wrote down supplementary. And then we turned that S into 180, and that's because it is actually an adds up to be 180-degree angle. So angle 1 and 2 make this straight line right here. And so since it makes that straight line, the two are supplementary angles. So we can find angle 2 by doing 180 minus 110, because we know that this is actually 110 degrees. And we get 70 degrees. So angle 2 equals 70 degrees. So let's try another example. So angle 1, which is over here, you can tell that that's in the top right corner of line M. And so if you look at line L, the top right corner has 60 degrees in it. So those two are corresponding. And so we can say that angle 1 equals 63 degrees because of corresponding angles. So number 2, we can look at line M, that it's a straight line. So that means that 1 and 2, angle 1 plus angle 2, must equal 180 degrees. And so we're going to do 180 minus 63, and that's going to give us our angle measurement for angle 2. And that equals 117 degrees. So angle 2 is 117. This makes sense because looking at angle 2, it looks like an obtuse angle, which means that it's going to be bigger than 90 degrees. So we can tell that 117 would actually fit where that angle 2 is at. All right, example 2, using corresponding angles. So we're going to use the figure to find the measures of the numbered angles. So we're going to find angles 1, 2, 3, 4, 5, 6, and 7 just by knowing that this is a 75-degree angle. So we know that right here is a set, corresponds with number 6 because they're both in the top right corner of our two lines. So we're going to find angle 1, 2, 3, 4, angle 5, and angle 6. And we know that angle 6 has to equal 75 degrees because they are corresponding and both of them are vertical or are parallel lines. All right. Now we can use supplementary angles to find out what angle 2 is. So angle 2 is located right next to 75 degrees, and it is a straight line. So these two angles must add up to be 180. So we are going to do 180 minus 75, and that's going to give us 105 degrees. So angle 2 equals 105 degrees. We know that angle 2 corresponds with angle 5 because they are both in the top left corner. And so if angle 2 is 105 degrees, that also means that angle 5 is 105 degrees. So now we just need to find angles 1, 3, 4, and 7. So there's actually two ways of doing this. You can use supplementary angles again and say that these two are supplementary angles and subtract. Or we can use our vertical angles theorem, which we talked about a couple units ago, which means that whatever angle is directly across from it, those two angles are equal. And so if 75 degrees is here, then that means that directly across from it is also 75 degrees, which means that angle 1 is 75 degrees. And again, we can check that because if angle 2 was 105, we could do 180 minus 105, and we get that 75-degree angle. So either way works. Both are correct, whichever way is easiest for you to remember. But I'm going to use vertical angles again. So 2 and 3 are vertical, which means they are equal, which means that 3 is 105 degrees. Now I'm going to use corresponding angles to figure out 4 and 7. So we know that angle 1 corresponds with angle 4, and angle 2 corresponds with 7. And so if 1 and 4 are corresponding angles, which means they're both in the bottom left side of their this figure, then we know that angle 4 must match up with angle 1, so that's a 75-degree angle. Oh, forgot to write number 7. But 7 is also going to correspond with 2, and 2 was 105 degrees, so angle 7 is also 105 degrees. So we were able to find out 7 different angle measurements just by using one known angle, which is actually kind of cool. So now I'm going to have you try number 3 on your own and check yours with mine. So I want you to hit pause and then check yours to see if yours match mine. So for angle 1, I got 121 degrees because I did 180 minus 59, and they gave me 121. Then using vertical angles, I found that angle 2 matched up with the given angle, which was 59 degrees. Using vertical angles again, only it's a vertical angle 1 and 3 are vertical angles, so those two match. So that's also 121. Angle 4 is corresponding with angle 1, so those are also 121. Number 5 corresponds with our given angle, which is 59 degrees. 6 corresponds with 3, so it's 121 degrees. And 7 corresponds with angle 2, or is also a vertical angle from 5, therefore it is 59 degrees. All right, so we are going to describe the relationship between each angle or pair of angles that are given. So in A, we are looking at 3 and 6. And so to describe the relationship between those two, we call those exterior angles. So they're on the outside, while these would be interior angles because they're on the inside. So they are exterior angles. And 3 corresponds with 7, which is a vertical angle from 6. So that means that angle 3 and angle 6 are equal. For 2 and 7, those are both interior angles. Sorry, I wrote with a highlighter. And since they're both on the inside of our parallel lines, they actually are equal because they are diagonal from each other, and 7 corresponds with 3, which is a vertical angle from 2. So those are also equal. So in the example, the angle 4 is actually 84 degrees. And so find the measures of the angles. So if that is 84, then what is angle 3? So we're going to do 180 minus 84. And that equals a 96-degree angle. So this is 96. Angle 5 is over here. And so we are going to try to figure out how can we get to angle 5 from for knowing that 4 is 84 and 3 is 96. So these two, just like 2 and 7 are interior angles, so are 5 and 4, which means that 5 and 4 are also equal. And I want you to do 6 on your own.